is there anything out there that seems to replicate what we're doing enough for us to maybe learn something about our relation to the planetary bodies? And how did you come? Because I'd like to, as quickly as possible, dive into the solar flare situation, because I guess so. I was reading, it was probably the Atlantic or some online article, and it was about how solar flares happen fairly often. And after I'm done this explanation, you could tell me how wrong my memory is, but that they happen every so often, and it's not a peculiar thing. However, if a really big one were to happen, which is not unlikely, then depending what part of Earth it hits, it could just wipe out all of the electricity that we have on that part of the planet, if not all of it. And so I read that. I remember putting the magazine down and just thinking, like, just how fragile our sovereignty and our life here is on our Earth. Like, you and I are having this conversation. I'm in Spain. You're in the U.S. and it's no problem. We think of it easily. But I went to bed, I remember that night, and I couldn't sleep because it was like, it was in Canada. You know how the Canadian winters are, and it was freezing. It was snowing outside. And I'm like, what would happen if we had a solar flare tonight? And then I ran through like a zombie apocalypse scenario in my mind. And the next day I was like, no more solar flare. So I'd love for you to expand or tell me where I was wrong, for like how impressive and also how dangerous these solar flares are if they reach us.
Yeah, so it's interesting that you start with the significant dangers of solar flares.
Right to
So
apocalypse.
yeah, so the way I normally start is the other way around. So being from Canada, you probably have seen Northern Lights.
No, I still haven't.
Oh, you haven't? Okay, I have traveled all around the world chasing Northern Lights,
Cool.
and Canada is just such a great place to see them, because in northern climates where the magnetic fields, when you look at the planet Earth, the magnetic fields we have a magnetic pole. The magnetic fields come out of the southern part of the planet and go in on the north side, right?
Okay.
So the reason I'm talking about that is that when we have a strong solar activity, and the way the sun works is that every 11 years we have a solar cycle. 11 years the sun is rather quiet. We call that solar minimum. Another 11 years, we call it solar max. Solar activity is high.
Okay.
So every 22 years you expect to have similar behavior ish. So when the sun is active, there are a lot of magnetic fields on the sun and a lot of charged particles. And the reason there are a lot of charged particles on the sun is that sun is just a massive nuclear fission reaction, right? So all of these very heavy ions or heavy molecules, atoms like iron and oxygen and so on, are constantly breaking down into hydrogen and helium, right? So that's how the sun is a nuclear reactor. But so during that process, there's a lot of energy that is being produced. But the sun is also very hot, and this constant motion of the very hot material to the surface of the sun causes this very strong magnetic field. And the other aspect of that is that because the sun is so hot, all of the atoms that I just talked about are losing all of their electrons because it's just so hot. Just like when you look at a neon lamp, what you're seeing is that because of a very strong electric field inside this neon lamp, the gas inside is
Okay.
ionizing, meaning that the electrons are separating from the atom and then or nucleus, and when they return together, they get excited and generate light, right? So the same thing happens on the sun too. So we have oxygen that instead of, if you've ever studied chemistry, you are normally used to O2 minus, which is gaining electrons. Whereas on the surface of the sun, because it's so hot, oxygen is 8 plus, meaning that all of its electrons have been ripped away from it, because it's just the electrons are so excited that they cannot stay with the nucleus. So that is the content in the solar atmosphere. So very strong magnetic fields, and they contain these just strong concentration of charged particles that we call plasma.
Okay.
So a good example of plasma on Earth is fire,
Right.
right? So it's simply when you have electrons and ions separated, so you don't have a neutral particle. You call that the gas. It's a gaseous kind of state. We call that plasma. And 99% of the universe is made out of plasma, not neutral atoms like
Oh,
air.
I did not know that.
Yeah. So we have the sun now, these magnetic fields constantly moving around, and once in a while we have both closed magnetic fields. That means that from one end the magnetic field comes back to the sun and
Mm-hmm.
closes. We also have field lines that are go all the way out to the end of what we call heliosphere, which is pretty much how far this magnetic fields from the sun can
So
propagate.
that's if there's a flare during the maximum of that 10 or 11 year cycle, it would go to the maximum radius of that heliosphere.
So the way it works is that we're still trying to understand exactly how the cycle comes
Right.
about. There's a whole process called dynamo theory that indicates how this hot material is coming up to the surface of the sun. But what you need to know is that these magnetic fields open and close. Once in a while start to come. So some of the field lines are facing north, some of them are facing
Okay.
south. And as soon as you have a north and south facing coming in contact, that's when we have just like when you connect two batteries, plus and minus, all of a sudden you get
Yeah.
this arc. The same thing happens for magnetic fields too, is that there's a process called magnetic reconnection. And reconnection is where two oppositely facing field lines all of a sudden start to reconnect and rearrange the field lines such that now this field becomes this and this, right? So that the, the field line remains still open and closed. And during that process is when you have this all of these charged particles that I told you are along these magnetic
Okay.
fields. So as soon as that reconnection occurs, all of a sudden, all of this plasma or charged particle is going to just eject from the sun.
Okay.
And that is the process we call coronal mass ejection. So it's just a mass that is being ejected from the sun or from the solar corona,
Right. And so
which
that
is,
ejection presents as a flare
so
because it.
that's only one of the
Okay. Because I
active
think we're going to need to
mechanisms
use
from.
more analogies here. Because like pretend that you're speaking to a golden retriever on this. Because as far as I
Yes.
understand space science, I do my best to read it as I find it fascinating. But like
Yeah.
once we get too far into like particles and eons and ions, I could sit here, focus as much as I can, and I'm not going to get it.
Okay.
I wish
Perfect.
I wish I would. But so you said so. The flare is just one type of ejection.
So that's coronal mass ejection is one type
Okay.
of ejection. And sometimes this, so think of it as the sun
Right.
sneezing. It's
Excellent.
just, a bunch of
Yeah.
a bunch of particles are
Yeah.
coming out all
Right.
at once. So that bundle, forget about that now. But so sometimes during that process, these field lines that have these charged particles are now, some of that plasma is going outward, some of it is going back toward the sun.
Okay.
The stuff that is coming back toward the sun is what causes the acceleration, or it heats up the plasma and accelerates some of the
Hmm.
plasma very much to the point where they're so hot that they start to emit in X-ray or soft X-ray, and that's flare.
Right.
So because flare is just light radiation, we see it within 8 seconds,
Okay.
because that's how long it takes for the light to travel from the sun
Right.
to
And there's
Earth.
no way for us to
And
know
that's what,
that it's coming.
but unfortunately, right now, no,
Right.
because the only thing we know right now is that Solar flares are associated with these dark spots on the sun. So if you just, looked at the sun, if you had a filter and you would be able to directly
Right.
look at it, or simply just have a reflection of it on a piece of paper, sometimes you see these dark
Okay.
spots on the sun. And those dark spots is what we call active regions.
Hmm.
Active regions are where magnetic field is strongest.
Okay.
So earlier I talked about solar cycle, right? So every 11 years, the number of these active regions is very small on the sun. Another 11 years, we have many large active regions, so many dark spots on the
Right.
sun.